Hey everybody, it's Guy McDoodfella, co-chair of the B-Sides Las Vegas Proving Ground track. Our next talk is Securing and Trusting Third-Party JavaScript in Your Web App by Krishna Chirumamilla, who was mentored by Gabriel Ryan.
Okay, hello everyone. Thanks for joining this talk about securing and trusting third-party JavaScripts. So in this talk, we are going to talk about the security of third-party JavaScripts, the risks and mitigations of these third-party JavaScripts, and also as a security team, when you're reviewing these JavaScripts, how to think about securing, how to think about keeping all the stakeholders happy, and also making sure that these third-party JavaScripts are secure. Here's a quick look at the agenda. We are going to look at the third-party JavaScripts and how they are used. We're also going to discuss the risks of third-party JavaScripts, then discuss how to secure them. We're also going to look at how tag managers are hard to secure. Finally, we are going to conclude with key takeaways. We'll start with intro and the definition of third-party JavaScripts. First, a little bit about myself. I'm working as a security researcher in product security team at Adobe. I've been in AppSec for the last 5+ years. Also, I'm a new dad. My newborn is using up all my energies, so it's definitely hectic right now. Outside of security, I love 3-hour plus hikes. Recently, I've also started investing time in understanding business models of different companies and also started learning about how cryptocurrencies and blockchains work. I also sometimes go out for a run if it's really nice outside. If not, just spend some time doing yoga. This is a little bit about myself. Diving into the topic of this talk, what is a third-party JavaScript? Right? Most websites today include content from other sources, often called third parties. As shown in this figure, third parties might provide anything from article content to avatar images to embedded videos. These are fetched to the web page with the help of a JavaScript, and the owner of the web page has not written this JavaScript. So the definition here is that a third-party JavaScript is a code that is being served from third-party servers and is not under the control of web page author. As mentioned before, these scripts are used not only for fetching content like images or videos, but also for analytics, ads, or even for some helper libraries. One good example is the social sharing buttons from Facebook and Twitter. Facebook or Twitter provides you with a JavaScript that you can embed into your website, and then when you run the website, you'll see the buttons on your site. So that is the definition about third-party JavaScript. Now let's look at how third-party JavaScripts are included in a web app. So how do you include these scripts? There are 3 popular methods. The first one is the script tag source attribute. It's a HTML script tag. And then the second method is using a tag manager like Google Tag Manager or Adobe DTM. The third one is to include the third-party JavaScript in a script tag. So this is like the most straightforward method. Let's now look into each of these methods in a detailed manner. The first method is the script tag source attribute. Using the script tag source attribute is very easy. You just use the link provided by the third party, and during runtime, the browser will send a request to the third party server and will load the script for the app to use its functionality. And here's the sample code. This is how it's embedded. As you can see, the script source attribute has the vendor.com/script.js. So during runtime, the browser will send a request to the third-party server vendor.com to get the script.js. It's as simple as that. And here's an example from adobe.com. As you can see, Adobe is using iPerceptions.js here. And then it's also using some JavaScript for Google Ad Services. And also it's using TikTok JavaScript, which is interesting. And all these are included with the script tag source attribute. And that is why I have shown here. The next method is the tag manager method. But before going into this method, let me just spend some time discussing about tag manager and what is a tag manager, right? Just like your content management system manages the content of your website, a tag management system manages the tags, which will allow you to insert bits of JavaScript, such as like the Google Analytics tracking code and all that. Typically, tag managers offer a web-based interface to choose, edit, and manage those tags when they are included in your web pages. So, like for example, if there's a non-tech savvy marketing folks in your company who are like trying to embed like JavaScript into your app's web pages, that's when they can use something like Google Tag Manager, and with like a click of a button, they could just embed whatever JavaScript they want to embed into your app. For example, if they want to track where the users are clicking on your app, that's when they can just add that with the click of a button, and then your app need not be deployed again and all that. So there are so many advantages for this. And here's a script from Google Tag Manager. We let Google Tag Manager know that we want to load some scripts like Google Analytics, Facebook like button, and a YouTube video. And Google Tag Manager generates a script for us to use in our app. This script can be embedded into your app, and it takes care of running all the scripts during runtime. So as you can see here in this code, you don't see any of those scripts, right? So you just see that the code is trying to include like script element. D.create element is it's creating a script element, and then it's creating it's adding the source attribute to that element, and then the source attribute is talking to Google Tag Manager.com server, and it's pulling the gtm.js script. And this script will have all the other scripts that your marketing folks or even developers wanted to include in your app. So it's as simple as that. And JavaScript always changes because whenever someone like tries to add more JavaScript or remove the existing JavaScript, that's when the JavaScript changes. But this script won't change much. And this is the most popular method, as I said, among marketing folks and also developers, because they don't have to redeploy app every time. And there are many advantages to this method. As I briefly touched upon before, let's look at them in more detail. So the tag management tools, as I have mentioned before, they separate the process of adding and updating like the tags from the process of altering your site's code. So really, we don't have to make any changes to the code to add a new JavaScript tag, and can do this with the click of a button from the UI. So this is like a really great advantage. And tag management tools also help keep track of all the added tags. This ensures that the tags are properly organized and the same tag is not added twice. So that reduces mistakes during development. So for example, you have already added a tag and you forgot about it, and then you add one more time the same tag. That's when the mistakes happen. So these mistakes can be definitely avoided with the tag manager. And tag manager tools also offer built-in debugging, testing, and preview tools for when a JavaScript is added, removed, or edited on a web page. So that is also another advantage. And additionally, these tools also offer version control to keep track of changes. And finally, like all good tools, these tools allow admins to specify who can view, edit, and publish tags. So any user who has access to these tags only can change or view them, so which is also great. So yeah, these are some of the advantages of why people use Tag Manager and why they are becoming more popular these days. And moving on to the next method of including third-party JavaScripts, this is the most straightforward method. You just get the script from the third party and embed it into your page in between script tags. As you can probably guess, your app won't be loading the most up-to-date version of the script. So you'll have to update and deploy your app whenever you want to update to the latest version of the script. And the code is pretty straightforward. You have a script tag. Instead of using the source attribute, you just copy the code from the vendor or any third party and then paste it in between the script tags, and then the code will do what it's supposed to do. This is also the most secure method because you know what you're including in the page, and this third party won't have control over the code. But again, as I mentioned, there's a disadvantage also. You'll not be loading the most up-to-date version of the script. And up until now, we have seen what's a third-party JavaScript and how it can be used. Now let's look at some of the real-world hacks, examples that happened because of poor third-party JavaScript security. The first one happened like this. It looks like the vulnerable website included a JavaScript library in a web page, and this library was pulling JavaScript from a hacked server. The JavaScript fetched from hacked server is malicious and is prompting the users or victims to install malware. Easily, they could do more to the users, like stealing of credit cards or personally identifiable information, etc. But in this case, they were just prompting the users to install malware. And really, all the sites that are possible with all the issues that are possible with cross-site scripting are also possible with this sort of vulnerability. Another attack that is in the news is the Mage cart attack. This is a very popular attack and shows how thousands of apps can be attacked at once. The attackers target third-party scripts being used in checkout pages, and by targeting and compromising these scripts, attackers collect credit card numbers of the users. Since many checkout pages use the same script, compromising one third-party script is enough for attackers to collect credit card numbers from thousands of victims. Here's the flow from the image. So first, vulnerable web apps fetch the malicious JavaScript from a hacked server. That is the first step. And then the malicious JavaScript sends the credit card info to the attacker whenever the users are using this vulnerable website. So all this happens without the users noticing any issue, and it's not just the users who won't be able to notice any issue. Even the web app owners won't be able to notice any issue with the app, and unless they go into the browser console and see where the requests are being made. So that is why this is like a really dangerous attack. And up until now, we've seen what a third-party JavaScript is, how they are used in a web app, and some real-world hacks that happened due to poor JavaScript security. Now, before looking into risks of third-party JavaScripts and their mitigations, let's understand what a DOM is. Typically, HTML elements in a page can be nested, allowing us to consider a web page as a tree of elements. The tree of elements is called Document Object Model, DOM for short. And as shown in this image, HTML element is the root node, and it has two child nodes, head element and body element, and the hierarchy continues. Like for example, the body node again has like two children, that is nav node and section node, and so on and so on. And one major advantage of arranging all the HTML elements in a tree format is that it allows JavaScript to programmatically access and manipulate the tree of elements. And this is what makes a web page more interactive. JavaScript accessing and manipulating the HTML elements. So really, if you think about it, JavaScript is the one that decides, or JavaScript that is running on the page is the one that decides what the user sees and what domains it can interact with and all that. So whenever user enters something, the JavaScript can decide. It can take that information that the user entered, and then it can ship that information to a third party or even to the owner of the web app. So that's how the DOM works, and that's why the HTML elements are arranged in a DOM format or a tree format. So yeah, like let's take just showing you where we are in the talk. So up until now, we have seen all the real-world attacks. Now we're going to discuss a little bit about the risks of these third-party JavaScripts in your apps. All these risks are on the client side because a third-party JavaScript is executed on the client side. The first risk is that a third-party JavaScript gets full access to DOM if embedded in an unsafe manner. Full access to DOM means arbitrary code execution privileges on the client side. As I mentioned, we have discussed a little bit about DOM. So if the third-party JavaScript has access to the DOM, that means it can execute whatever it wants to. The second risk is that we also have the risk of leaking sensitive information to third parties. Like in the Mage card attack, third parties or attackers could get sensitive information like credit card numbers, personally identifiable information, etc. And the final risk is that the third party controls changes to the script. That means they can change what they are executing on your client side and what they are collecting from your users. So initially you might have reviewed the code and you might be like, okay, this is not harmful, or this is not doing anything dangerous on my web app, so I'm going to include this JavaScript. But then once you include the JavaScript, then it can the owner of the JavaScript can change the content of the JavaScript and what it does on your web page. So yeah, these are the main risks with the third-party JavaScripts. And now that we have seen risks, let's talk about how to mitigate these risks. And before discussing the mitigation techniques, let's talk about content security policy for a bit. Content security policy is an additional layer of security that helps to mitigate attacks like cross-site scripting, information leakage, etc. And this is more of a browser security feature, but server has to tell the browser what to secure. And a popular way is that a server sends a content security policy directive in a content security policy header. As I'm showing here, there's this content security policy header, and then there's this directive default source, and then there's a domain, which is example.com. And just to talk a little bit about this default source directive, this directive tells the browser from which origin all the content of the web page should come from. So here the browser, the server is telling the browser like, hey, only load the content that is coming from example.com, or execute the content that is coming from example.com. And based on this, if the browser sees a request to fetch a JavaScript file from malicious.com, the browser won't send the request because the content security policy didn't say so. So it's as simple as that. And there are more directives like this. For example, there is a script source directive, which tells the browser to from which origin the JavaScript files are to be loaded. And there's also another directive which instructs the browser to which domains it should make a request to. So there's so many browsers, so many directives which you can look into and learn more about content security policy. And content security policy is important for our first mitigation technique. And so now that we got content security policy definition out of the way, let's look at the first mitigation method. So the first mitigation method is to use content security policy with a nonce. A nonce is a pseudonym for number used once, so the nonce changes every time. And script source directive of a content security policy tells the browser to load scripts from a specific domain, or if a certain condition is met, as I have just mentioned before. There's also where in the directive you can also specify only load the JavaScript if a certain condition is met, not just from a certain domain. And whenever you have a nonce in a script source directive of a content security policy, all JavaScripts on the page must have the nonce attribute with the same nonce for these JavaScripts to be executed. So for example, as you can see here, like this script source directive has like nonce random value, and in the page, if you see like script tag, if the browser sees script tag and if it sees nonce random value, then it executes the function, which is kittens in this case. But if it sees the script tag with the nonce other value, then it will not execute the function evil. So this is great because all the third-party JavaScripts will have this nonce random, which is only known to you. And if the attacker tries to have like a different nonce value, attacker won't be able to guess the nonce value in the first place. And if the attacker has some other nonce value, then that will not work. That will not execute the script. The browser will not execute the script. This is a good first step towards the third-party JavaScript security, but it doesn't validate what the JavaScript is doing. But it's more like telling the browser that we trust this JavaScript and it can be executed. If the third party, who's the owner of the JavaScript, decides to change the JavaScript, we won't know that and script still gets executed. The third party server is hacked and the JavaScript is changed to do something malicious on the websites it is executed, the JavaScript still gets executed. As I said, this is more of like a initial check, telling the browser that, okay, we trust this JavaScript, but it still exposes us to risk. Moving on to the next mitigation technique, putting a third-party JavaScript in an iframe is a better solution than the one that we discussed before, and it won't give access to our page DOM. If you think about it, accessing the DOM is the biggest risk, and so it will definitely eliminate that risk. Because iframe will be given a different DOM even if it's in the same page, and so that definitely is secure. So mostly as a security team, we are comfortable with this solution, but modern JavaScripts, especially those that do analytics or tag management, they need access to the DOM, and solution to put this JavaScript in an iframe won't go well with the development teams. And the final mitigation we are going to look at is the sub-resource integrity. The JavaScript is put through a hashing algorithm, and the resulting hash value is used in the integrity attribute of the script tag. So as you can see, we have the script tag here. The source attribute is telling the browser to load JavaScript from Cloudflare CDN, and there's the integrity attribute. The integrity attribute is where the developer puts the JavaScript that he or she knows, and the JavaScript is taken and put through a hashing algorithm, and then a hash value is added to this integrity attribute. And the hash algorithm being used here is SHA-256, which is fine. And during the runtime, the browser fetches the hash value, fetches the JavaScript, and then it puts the JavaScript through the same hashing algorithm and then calculates the hash value. If the hash value matches, that's when the script is executed. If the hash value is not matched, the script will not be executed. So if you and also the browser will throw this error in its console. So if you think about it, this is like a great mitigation. It ensures that only scripts that we have reviewed are executed. Ideally, you would have reviewed the script before using it in your app. So yeah, this is a great mitigation technique. And but still, do you think this is like an ideal solution? In an ideal world, yes, this is an ideal solution. But let's look at why sub-resource integrity might not be a good solution, especially when it comes to dynamic JavaScripts like the ones that we get from tag management solutions. Sub-resource integrity works great for static third-party JavaScripts, and modern tag managers dynamically change the script. This is something we have already looked at. So the JavaScript, the container script is the same, but the JavaScript can be changed at the click of a button. So it changes very dynamically. So tag managers allow, like as I mentioned before, tag managers allow even non-tech savvy folks to add different scripts with a click of a button. And this means that scripts are changed dynamically, right? So when the scripts are changed dynamically, we can't use sub-resource integrity. And this is the point that I'm trying to get at, because using sub-resource integrity means that whenever a script is changed, the integrity attribute also has to be changed. That means the app has to be deployed again. Deploying the whole app for minor code changes is what we are trying to prevent with tag managers. And but with SRI, we are back to where we started. So the development team says we don't want to use sub-resource integrity, and iframing the JavaScript also doesn't work for us. So what do we as a security team do in such scenarios? In such scenarios, we ask the team to use content security policy nonce as a good first step. Additionally, we should understand where this script is being used. If the script is being used on a sensitive page with password change functionality or checkout functionality, then we usually recommend them to not include the script in those pages. But if it's being used in other places where future script changes or sensitive information collection is not a big deal, and we trust the third party, then we should be good. And by trusting the third party, I mean, if we entered into a contract with them and reviewed their security practices and security posture, then that's okay. This is where your vendor security team and legal team comes into play and reviews the vendor. It also helps to educate folks who are using the UI of the tag management systems, mainly because they could be adding any JavaScript into the web page, right? So it's definitely it definitely helps to educate them about the risks of this, and then make sure that for most of the changes they review that with someone with the security knowledge. Okay, concluding the talk with key takeaways. The key takeaways are third-party JavaScripts are risky, as evidenced by the recent hacks and the risks I have outlined. But these risks can be mitigated with the mitigation techniques we have discussed. And sometimes it's not possible to mitigate these risks, especially in the cases where the script needs access to the DOM and is dynamic. In such cases, we assess the risk, trust the third party, and accept the risk. And yeah, thanks everyone for joining this talk. I would like to take this time to thank Gabriel, who helped me with this talk. If you have any questions, happy to answer them. Thank you.